Measures of central tendency, otherwise known as, we're talking about data and specifically mean, median, and mode. Here are the learning goals for the lesson. By the time we're done, you should be able to calculate measures of central tendency, specifically mean, median, and mode, for various numeric data sets. You should be able to analyze the impact of outliers, which means identifying data points that are significantly different from the rest and explain how they influence the mean and median. And finally, determine which measure, mean, median, or mode, is the most appropriate to represent a specific data set. So first of all, what is data? Data is a number of things. We can say it's units of information collected through observation. It is usually numeric, but not always. It's collected, measured, analyzed, and reported. It's able to be visualized in graphs and charts. And it's helpful to understand relationships and to make predictions. Various industries use data. Just about every industry is data-driven to some degree. Certainly in research, that's the number one thing. If you go into any university course, guaranteed that you're going to take a course in statistics, which is all about data. Business management, if you're running your own business, you want to be able to collect data about sales, salary, budget, inventory, improving profits, and so on. If you're in finance, spending, budget, investments, all of those things are data-driven. If you're in government, if you're in a political party and you're running for re-election, you do polling to find out whether your party is popular or what policies are important to people. In education, we have statistics. We collect data on the number of students and where they come from and what their learning abilities and challenges are, all that kind of stuff. There's all sorts of data. And in natural resource management, we look at how many resources we have, how much we're being used, how long it'll be before they run out, that kind of thing. So any place you work, you're going to be working with a lot of data. We can organize and summarize characteristics of a data set by using measures of central tendency. So if you get a whole lot of data and you want to kind of sum it up a little bit, a measure of central tendency kind of helps you to do that. You've done these before, certainly in grade 8. You've talked about mean. Another name for mean is just the average. We take all of the data values, we add them up, then divide them by the number of data values that we just added. That gives us the mean. Then there's the median. This is the middle value of the data. So first you need to put all of the data into order from smallest to largest, then choose the one that's right in the middle. If there are two middle values, then you take their average. And finally, there's mode. Mode is the value that occurs most often. And there can be more than one mode, so you can have a tie. Let's look at an example. The age of players on a baseball team is listed below, and we're asked to first calculate the mean. So to do that, we need to take all of these numbers and add them together. If we add them all together, we get 325. And we can see that we've got 10 pieces of data, so we've got 10 ages. So to calculate the mean, we just take that 325 and divide it by 10, which gives us the average age of 32.5, or 32 and a half years. To calculate the median, we have to first put them all into order. So we've got a 22, then we've got another 22, then we've got 27 and another 27, then we've got 28 and a 31 and a 33 and a 39 and a 41 and a 55. Once we've got all of the numbers in order, we can count them up and see if we can find the exact center. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. Unfortunately, that means there is no exact centerpiece. The center of this series is right in between 28 and 31. So to calculate the median, we have to take the average of those two values. 28 plus 31 divided by 2. It's 59 divided by 2, which equals 29 and a half. The third part says to calculate the mode. Remember, the mode is the number that appears most frequently. So we can see we've got a 22 and a 22, but then we've also got a 27 and a 27, and those are the only duplicates. None of these others here are duplicated. So we can say that the mode is 22 and 27. Those are the three measures of central tendency for this data set. You can see from these three graphs that your data, depending on how it's distributed, can have a different shape. If it's evenly distributed between on the left and right side of the center, as you see in this first one, you end up with a very symmetric distribution, and in that scenario, the mean is equal to the median. In a right-skewed distribution, the mean is further to the right of the median, which means the average that you calculate is higher than the central point of the data. And similarly, a left-skewed distribution means that your mean is to the left of the median. If we want to know which of the measures of central tendency to use that best describe the data that we've got, there are some things that we want to consider. If we have outliers, in other words, numbers that really don't fit with the rest of the sets of data, we would typically then use the median number. The example that we show here, 1, 2, 3, 4, 40, the 40 is really an outlier. It doesn't fit very well with the other data sets. Because the 40 is an outlier, we're going to choose the median value, which in this case would be 3. If the data is skewed, we typically use the median, and it will be skewed if we have a very strong outlier, as we did in the first example. If the data is symmetrical, we can use either the mean or the median. They'll be quite similar typically. So in this case, the median value is 4. If we calculate the mean, we take 1 plus 2 plus 4 plus 5 plus 6, so we get 18. The total is 18. And we divide that by 5, which gives us 3 3/5, or 3.6 if you like decimals better. And certainly 3.6 is fairly close to the 4. So there's our mean, and our median was 4. Try to fill in the blanks here to make sure you understand the different definitions. Pause the video and then try it out. The answer here is median. So the median is the center number. So the median of a numerical set of data is the middle number when the numbers are written in numerical order. The mode of a numerical set of data is the value that occurs most frequently, and the mean is the average of a set of data calculated by dividing their sum by the number of data points. Let's look at a real-world problem. You and your friends are having a friendly competition about the scores of your math quizzes. Both of your scores for the first 5 quizzes are given below. You've got your quiz and your friend's quiz. We're asked to find the mean, median, and mode of both data sets. So we're going to start with you first of all. Starting with the mean, we have to take all these numbers and add them up, and they add up to 85, and then we have to divide them by the number of data points, and we've got 5 data points. So the mean is 17. The median means we have to get all of the numbers first of all and put them in order. So we start with 15, 16, 17, 18, and then 19. The median then is the one right in the middle, so the median is 17. And finally the mode. There is no mode to this data because there's no number that's repeated more than once. All right, let's look at your friend and calculate their mean. They've got a total of 82 divided by 5, which is equal to 16.4. To do their median, we need to put their numbers in order. We've got 12, 13, 17, 20, and again a 20. And their median is also right in the middle at 17, but they do have a mode. Unlike your data set, they have a mode of 20. So if we compare means, your mean is higher than theirs. So using the mean as the measure of central tendency to represent the data, your mean is higher, so it looks like you're doing better. If we choose the median, they're both the same, so it looks like you're doing the same. However, if we look at mode, you don't have a mode, but they have a mode of 20, so their highest possible mark is their mode. So using mode as the measure of central tendency makes it look like they're doing better. To answer the question, you have the higher mean. Here's a data set. Let's figure out the mean, median, and mode. To find the mean, to calculate the mean, we have to add up all the numbers and then divide by the number of pieces of data. In this case, there are 7 pieces of data. We add them up and we've got 28 and we have 7 data points, so that means the mean is 4. To find the median, we need to put all that data in the correct order. We've got 2, 2, 3, 5, 5, 5, and 6. The median in this case is right in the middle, and that's a 5. The mode is also 5 because there are 3 of those. Here's another data set. You can try this one on your own and then come back and look at the solution. It's a little bigger for you to see. We total them up and we've got 105 divided by 7. Dividing that out gives us 15, so the mean is 15. To find the median, we need to put all of the data in order. 10, 10, 12, 12, 15, 22, and 24. Looking for the middle piece of data, we see that that's 12, so that is our median. Finally, the mode, we have a double mode in this case because there are 2 10s and 2 12s, so our mode is 10, 12. Here's another example. We want to add up all the numbers and then divide by 6. The total is 108. We're dividing that by 6, which gives us 18. So the mean is 18. That's the average. Then to find the median, we need to put them all in order. 13, 16, 13, 15, 18, 16, 18, 21, 25. Now we've got a little bit of a problem because the central point, there is no central number because we've got an even number of data points. So that means we need to average out those two values. The average of 16 and 18, we have to take 16 plus 18 and divide by 2, which gives us 17. Not surprisingly, it's the point right in the middle of those two numbers. So our median is 17. We look at this data set, and again, we don't have a mode. Let's consider this problem. Which measure of central tendency is the most appropriate and why? Sometimes one measure of central tendency provides more meaningful information about a situation than another. In this example, students have taken a vote on the new official school colors. The rainbow illustrates how many students voted for each color. So 7 voted for red, 4 for orange, 1 for yellow, 5 for green, 6 for blue, and 10 for purple. Which measure of central tendency would be useful in determining the winning school colors? Here's the solution. The data collected involves the number of students that chose a particular color. Therefore, the winning color should be the one that was chosen the most often, or the most popular choice. In this case, neither mean nor median of this data would provide any meaningful information about the color chosen. They instead provide information about the number of students involved in the vote. Therefore, the best measure of central tendency to use in this case would be mode, as this would tell us the color that was chosen the most often. Therefore, purple wins. Now let's look at another example. Mohammed and Zaina's weekly quiz scores were the following levels: 1, 3, 2, 3, 4, 4, and 3. Which measure of central tendency would be the most useful to describe the data and why? Okay, as a teacher, personally I'm suspicious as to why their test scores are exactly the same. But anyway, moving beyond that, the mean of the data is the average, so we add them all up and divide by 7, and we get 3. The median value of the data is, if we put them all in order, is also 3. And the mode of the data is 4, since it appears the most times. They got 4 3 times. So which of these is the better measure? Which one indicates how well they're doing? Since the mode in this case represents the highest score only, it's not the best representation of the 7 scores. Both the mean and the median, however, provide useful information about the data. I would add, though, as a teacher, if I'm looking at the data, if the data occurred in this order, where this was their first test and this was their most recent test, what it also shows me is that their data scores seem to be, their test scores are improving. They were being pretty consistent for those 3, and then they slipped up a little bit here, but they're certainly doing better than they were right at the start of the course. So from that perspective, I might lean a little bit towards the mode, as long as we see more data along here, they start to give me more 4s. Sometimes one measure of central tendency provides more meaningful information about a situation than another. Let's look at this example. Flora paid the following amount for the last 5 pairs of jeans before tax: $55, $12, $49, $125, and $35. Which measure of central tendency would be the most useful to describe the data, and why? The mean of the data is $55.20. The median is $49, and there is no mode. The largest value of $125 is very different from the other values. We could call it an outlier because it's so different. It has a big impact on the mean, but not much impact on the median. Therefore, in this case, the median is the better measure of central tendency for the given data. To summarize, the mean is the best measure of central tendency to use when the data provided consists of numbers that are all relatively close to one another and the data is not skewed. The median is the best measure of central tendency to use when the data provided consists of numbers that are all relatively close to one another and the data either contains outliers or the data is otherwise skewed. And the mode is the best measure of central tendency to use when the data provided represents the frequency of choice. Now it's your turn to tackle the homework. To find the mean, we add them all up. We end up with 120, and we have 7 data points. 120 divided by 7 gives us 17.14. So our mean is 17.14. Our median, we've got to put them all in order first of all. We've got 10, 12, 17, 18, 20, 25, and 31. And the median is the point right in the middle, which is 18. In our case of mode, again, we do not have a mode. To find the mean, we add them all up, and we come up with a total of 282. Divide it by 6 because we have 6 pieces of data. And when we calculate that, we get a mean of 47. To find our median, we have to put them all in order. So we start with 40, then 43, 46, 48, 52, and 53. But we've got an even number of data, so the median falls right in the middle. In this case, the distance halfway between 46 and 48 is 47. And again, there's no number that's duplicated, so we have no mode. To find the mean, we have to add them all up. Total of 70, dividing it by 5 pieces of data, that's 14. The median, we need to put them all in order. 8, 9, 10, 15, and 28. And the middle piece of data is right there. So the median is 10. And again, no mode because there is no number duplicated.